Okay, the second secretion is gastric lipase, secreted by the chief cells. And I try to think of ways to remember what they do. Well, lipase to me kind of sounds like lipids. So gastric lipase secreted by the chief cells, and sure enough, it digests lipids. It digests lipids. Okay, the third secretion again is mucus. Mucus cells secrete a thin layer of mucus. Mucus cells secrete a thin layer of mucus. It protects the stomach lining from the acid. Protects the stomach lining from the acid. So if you've ever wondered with hydrochloric acid, this is real pH of 1 hydrochloric acid that we secrete. Why does it eat away the stomach? It's because we constantly make this mucus membrane, mucus, secretion, and that helps to prevent it. Now, you don't have to write this down. Sometimes people over-secrete acid or under-secrete mucus, and then that's what gives rise to an ulcer. It's like a burning blister within the wall of the stomach, so obviously that would not be pleasant. And then the last secretion is intrinsic factor. Intrinsic factor is secreted by parietal cells, and it helps with the absorption of vitamin B12 into the blood. Secreted by parietal cells, helps with the absorption of vitamin B12 into the blood. Okay, when you're ready, next page. Okay, now of course we need to regulate our gastric secretions. We certainly want to secrete them when they're needed, but we don't want to secrete them when they're not. And we find that there are two substances involved in the regulation of gastric glands. The first is somatostatin. That should sound kind of familiar. Somatostatin is a hormone, and it's secreted by cells near the parietal cells. Secreted by cells near the parietal cells. And what it does is it inhibits the secretion of HCl, which is hydrochloric acid. It inhibits the secretion of HCl, which is hydrochloric acid. Okay, but there's another regulator of the gastric secretions, and that's acetylcholine. Again, that should sound familiar. If you remember, acetylcholine is classified as a neurotransmitter. And acetylcholine does two things. It suppresses somatostatin and allows for the secretion of hydrochloric acid. It suppresses somatostatin and allows for the secretion of HCl, hydrochloric acid. Suppresses somatostatin, allows for the secretion of hydrochloric acid. Okay, so when we need the acid, okay, somatostatin has to lay off, and acetylcholine can override it. But the second thing acetylcholine does is that it stimulates cells in the pylorus to release the hormone gastrin. Stimulates cells in the pylorus to release the hormone gastrin. G-A-S-T-R-I-N. Gastrin stimulates all gastric juice release. Gastrin stimulates all gastric juice release. Okay, so all the secretions from the previous page. Okay. Now, the interesting thing about digestion in the stomach is that when we're digesting the food that arrives in the stomach, it's not just all bombarded all at once with all the gastric juices. Rather, it occurs in 3 steps or 3 phases. The first phase of gastric juice secretion is called the cephalic stage. The cephalic stage secretes between 30 and 50% of our gastric secretions. It secretes between 30 and 50% of our gastric secretions. And cephalic, if you're familiar with that term, it means something with the head, and this kind of fits. So under A, it controls the psychological influences of food. It controls the psychological influences of food. Such as the smelling, the thinking, or the first taste of food. Controls the psychological influences of food, such as the smelling, thinking, or first taste of food. So what I'm telling you is that the cephalic phase begins before food enters the stomach. Okay, that's what's interesting. Before food enters the stomach. So if you're hungry, can't wait to get out of here and get something to eat, and you start thinking about what do I want to eat, you're starting to release gastric juices because your stomach is thinking, okay, it's going to be coming, I'm going to get all ready for the food, okay? Or if you like something and you can smell it, and it doesn't matter if you're hungry or not, think, gee, that smells good, stomach thinks, oh boy, here it comes, you know. Or the very first bite, even before you've done chewing and swallowing it, we begin to get the stomach ready for the food. So it's like, you know, here I am, come, okay? All right, then the second phase kicks in, which is called the gastric phase. This accounts for 40 to 50% of the gastric secretions. Okay, now what happens under B is food arrives in the stomach, which stretches the stomach wall. Food arrives in the stomach, which stretches the stomach wall and that stimulates gastric secretions. Food arrives in the stomach, it stretches the stomach wall, and that stimulates gastric secretions. Okay, now under B, we've got to talk about acid especially, okay? A pH of 4 or more in the stomach. A pH of 4 or more in the stomach indicates the need for acid. A pH of 4 or more in the stomach indicates a need for acid. Now, most foods we eat come in at a pH of about 7. They're neutral. So just about every time we eat, we need acid, okay? So you ate whatever you ate. It has a pH of 4 or more, and that means we need acid. Okay, still under B. Acid is secreted, and when the pH reaches a 3, the acid is inhibited. In other words, it slows down. Okay, so acid is secreted. When the pH reaches a 3, the acid is inhibited. In other words, it slows down. Then when the pH reaches a 1.5, secretion of acid stops. When pH in the stomach reaches a 1.5, secretion of acid stops. Okay, so let's go back. In the cephalic stage, let's just say we first tasted the food. Okay, then the stomach started to secrete before we even swallowed. In the second phase, as soon as the food hits the stomach, we release all the secretions, but acid is very, very sensitive to the pH. If we have a pH of 4 or more, we're gonna release acid. That's just about all the time. When that pH goes down to a 1.5, then we don't need any more acid. Okay, it stops. But then there's one more phase that needs to kick in. It's called the intestinal phase. This accounts for between 5 and 10% of the secretions. And it begins when food first enters the small intestine.